Hi everyone. Today we'll be discussing the LeetCode problem of the day, maximum frequency of an element after performing operations, part 2. In this problem, you are given an integer array nums and two integers k and num operations. So you must perform an operation, this num operations many times on these numbers, where each operation you have to pick any of the index that was not already selected, and to that you can add any number from the range minus k to plus k. And at the end, you have to return the maximum possible frequency of any element in the numbers after performing these many operations. So for example, we have 145 and k equal to 1 and two operations. So in first operation, you can uh, leave this one as it is, like I won't perform any operation on this. And I'll use my first operation on this 4 to make it 5. And I'll use my second operation to add a plus 0. So this will remain 5. So this is my resulting array after performing exactly two operations. And in the resultant array, I can see that the maximum frequency is 2, which is of 5. So 5 has a maximum frequency 2, so we return 2. Now in the second input, we have 5, 11, 20, 20. In this array, the maximum frequency is already 2, and you are given k equal to 5 and number of operations is 1. So by doing one operation, you can't transform any of these two numbers to 20 to increase our frequency. So the maximum answer will remain 2 only. So suppose the k value was maybe 10. So in that case, for this number, we can add a 9 because 9 is in the range minus k to plus k. So to this number, we can add a 9 to make this 20 using one operation. So now the new answer will be 3 because the frequency of 20 is 3. But since k equal to 5 only, the output will be 2. And the only difference between the part 1 and part 2 of this question is the constraints. So the array length is same, which is 10 power 5 in both versions. But the only difference is each element is up to 10 power 9 and the value of k is also 10 power 9 here. In the previous version, the range is only up to 10 power 5. So the only difference here is the number and the k, which can go up to 10 power 9. Now let's go with the approach. So we'll just look at the approach through this example. We have 3, 5, 6, 7, 7, 7, 9 and k equal to 2 and number of operations equal to 2. So each number, suppose we have 6. So 6 can be modified in the range 8 to 4. Because k equal to 2, the maximum we can add is 2. So maximum 6 can be reached is 8. And the minimum it can be reached is 4 when we add a minus 2. So similarly, for every number, we have a range that it can be modified to. So 3 can be modified from any number between 1 to 5. So let me just write all of this in this number scale. So first we have 3. So 3 can be modified from 1 to 5. So this is the range of 3. This is the 3. So now we have the next number, which is 5. So 5 can be modified from 3 to 7. And next we have 6. So this is the number. 6 can be modified from 4 to 8. And next we have 7, for which 7 can be modified from 5 to 9. And we have 3 7s, so I'll just repeat this 3 times. This is going extra. And finally, we have a 9. And 9's range is from 7 to 11. So we have 9 here. And its range is from 7 to 11. So at the end of the day, we just want to make the numbers with the maximum frequency. So here we can see that only one number can be made to reach 1, and only one number can be made to reach 2. And for 3, 2 numbers can reach this 3. Okay, for this one. And for this 3, 2 numbers can be reached 3. And for the 4, you can see 3 numbers can reach this 4. And for 5, 1, 2, 3, 4, 5, 6, 6 numbers can reach 5. For 6, we have again we have only 5. For 7, 1, 2, 3, 4, 5, 6, 6 numbers can reach 7. And for 8, 1, 2, 3, 4, 5, 5 numbers. For 9, 4 numbers can be reached. For 10, only one number can be made to reach 10, which is the 9. And 11 also, only one number can be made to reach 11. And for 12, we have 0. So well, let's just take 5 as an example. So for 5, 6 numbers can reach 5. So out of those 6 numbers, first we'll see how many numbers are originally present in the array. So out of the 6, one number is already present in the array, which is equal to 5. And the remaining 5 numbers, we have modified them to reach the 6. So we can see we have 6 numbers. In that, only this blue, only one number is originally present, and the remaining 5, which is this, and this, all these numbers are modified so that they will reach this 5. So 5 numbers are modified to reach the number 5. So out of this 5, since we have a limitation that we can only modify 2 numbers. So out of this 5, we can only modify 2 numbers. So that total actual numbers that can reach 5 is equal to only 3 because of this modification. So what we need to do is for each number in this range, we just need to check how many numbers actually are reachable, because this number will give you irrespective of the limitations. So when you apply the limitations for each number, you need to find what is the actual value we can reach. So, but by doing this, since we have the constraints as 10 power 9, we can't iterate on 10 power 9 elements. And we can't also create a array size of 10 power 9, because that will give you memory out of bound. So instead, what we do is, one thing is clear, that we need to find the answers which is already present in the array. So suppose if we take a 7 in this example. So if we take 7, 6 numbers are can be made to reach 7. So out of these 6 numbers, 3 numbers are already present in the array. So 7 is already present in the array 3 times, and the remaining 3 numbers are formed by doing transformations, which is this, this, and this. So all these 3 numbers are transformed to reach 7. And out of these 3 numbers, we can only modify two numbers because we have a limitation of 2. So the total answer is 5. So by this, what we can see is we can get a maximum answer by checking all the numbers from the array. So we can check 3, we can check 5, 6, 7, 7, 7, and 9. We can only check these numbers instead of all the other numbers to get the answer. But here we can see we have a range. For each number, we have some range. So currently we are only checking the middle number of the range in this array, because the array elements contain only the middle numbers. So far, we are planning to only check if the final answer lies among these numbers. But if you see this example, in this example, the final answer lies when you transform these numbers to 10. So 2 remains same, 8 will be made to reach 10, and 11 will add -1 to make it 10. So in this example, we can see that the answer will not always lie in the array itself. So it can be somewhere in between. So, and also we can't check all possible numbers. So we need to see what numbers we need to check, so that we will cover we'll cover our answer. So from this diagram, we can see each number has a range. So 3 has a range -1 and 5. So when we check 3, we also need to check 1 as well as 5, which will cover the starting point and the ending point of the whole range of 3. And when we check for 5, we also need to check whether answer can lie at 3 and answer can lie at 7. And similarly, when we check for 6, we also need to check for 4 and for 8. So what I mean to say is the answer can lie anywhere in these numbers, and also the answer can lie at the extreme points of the ranges. So when we check the original numbers and also the extreme points of the numbers, we can find the maximum frequency after all the transformations. Okay. So for each number in nums of I, we need to check whether nums of I can be the answer, and we also need to check if nums of I plus k is the answer, and we also need to check if nums of I minus k is the answer. So these are the boundaries. This is the left boundary, and this is the actual number, and this is the right boundary. So we just need to iterate the array, and for each of the array numbers, we need to check for all these numbers whether this can be our potential answer. That means after the final transformations, the maximum frequency will occur at these points. So now the question arises is how can we find what is the maximum frequency of this number without taking that array, because we can't create an array of such size. So for that, what we can do is suppose, for example, in this array, I want to find how many numbers will lie at 7. So my current target is 7, and since k is 2, my range will be from 9 to 5. So what I'll do is first I'll sort the original array, and in this array I'll perform a binary search to find the range of this 5 and 7. So ideally that means in this array first I'll find the smallest index which is greater than equal to 5. So from this array we can see this index 1 is the smallest index which is greater than equal to this 5. And also I'll perform a binary search to find the greatest index which is less than equal to 9. So from this array, this is the greatest index which is less than equal to 9. So index 0, index 1, 2, 3, 4, 5, 6. So for 7, all the numbers from index 1 to index 6 can be modified to each 7. So the total number of numbers is 6 minus 1 plus 1, which is 5. 6 minus 1 plus 1, which is 6. So that means 6 numbers can be transformed to reach 7. So we have the total number as 6. Now in this 6, like we discussed, we need to find how many numbers are originally in the array. So for that, we can maintain a frequency map, and we can maintain a hash map. So from that, we can get 3 numbers out of the 6 are already present in the array as a form of 7. And the remaining 3 are obtained by transformations. And out of these 3, again, we can only use 2 of them because number of operations is only 2. So we can formulate it something like this. The answer is frequency of x plus minimum of this extra, I can say modifications, comma the num operations. So here the modifications is 3, but the minimum operations is only 2. So this minimum will only return 2. So here the answer will be 5. So we have checked the same for 7. So we need to check the same thing for 5 and also for 9, because we want to check for the boundaries, the center, the left and the right boundary. Now let's go over the code. So first step is we will sort the array so that we can perform the binary search and also maintain a hash map. And let's just fill the values in the hash map. So in numbers map dot put. So here we are just increasing the frequency of the numbers, and for the first time this value will be null because it will not be present in the hash map. So we can write get or default num comma 0. So if it's not present, this value will be 0, and to that you are just adding 1. And for this, each time it will just get the frequency and add a 1 and put it back in the num. So here we have created a frequency map. After that, let's just iterate on the numbers. Num in nums. So for each of this number, we need to check for num. We need to check for num minus k, also num plus k, whether each of these 3 can be our potential answers, where the maximum frequency will lie. So for that, since we are doing it 3 times, it's better to create a function. Let's just say, let's just name the function as count. I'll just pass the number and the number array, a num operations, and also the map. Let's just quickly fill the function. So the number is x, and array, we have array, and then we have k, and then number of operations, and finally the map. So here what we need to find is we have the number x, and we need to find the range of x minus k and x plus k in this array. So initially, let's just take left equal to -1 and right equal to -1. And for performing the binary search, L equal to 0, R equal to array dot length -1. And now we can just start a binary search. L is less than equal to R. First get the mid by 2. So let's take an example. In this example, we have 3. So first we have 3. So we need to find the numbers in the range 3 minus k to 3 plus k. So 3 minus k is how much? 1, and 3 plus k is 5. So from this array, we need the numbers from range 1 to 5. So ideally, we need these numbers, index 0 and index 1. So first, we are interested in the lower bound. That means we need to find the least index which is greater than equal to the number 1. So when we do the when we get the mid, so first we'll check if our mid is greater than equal to x minus k. So if it's already greater than equal to x minus k, then we have found the answer, left equal to mid. And since we want the least value, we'll move to the left, are equal to mid minus 1. And else in the sense the current number is less than x minus k. So we found a number which is less than this, so we need to move to the right to find a bigger value. So right will be mid plus 1. Sorry, left will be mid plus 1. So by doing this, we find left equal to index 0. So left will be here. And we can follow a similar approach to find the right. Let me also initialize these variables again. Left equal to 0 and right equal to array dot length. But in this case, we want to find the maximum value which is less than equal to x plus k. So my number if my mid value is less than equal to this, then I can say right equal to mid. And I want to find the maximum value, so left equal to mid plus 1. Else in the sense my mid is greater than the x plus k. So I am beyond the number, so I need to come back. So for that, I'll just do right equal to mid minus 1. So after doing this, I'll get my right value as here. So the total number of elements will be, so for that I can say total will be right minus left plus 1. So in this case, our total value equal to 2. So we can see from this array as well, 2 numbers lie in the range 1 to 5. That means 2 numbers can be made to reach 3 after the transformations. And out of these 2 numbers, first we need to see how many are from the frequency. So say frequency equal to app dot get dot default x. So in this case, our frequency is 1 because 3 is present in the array. And the remaining 1 is from the modifications. And out of these modifications, we can only transform this num operations. So we need to apply a minimum on both of these modifications and also the num operations. So at the end, we can just return frequency plus minimum of and also the modifications will be total minus frequency. So we return frequency plus math.min of the modifications comma the num operations. So this will return how many elements can be made to reach num. So we can also store it in an answer. Initially answer, let's say 0. So answer equal to math dot max answer comma count. So for 3, we get the answer as 1 plus 1 equal to 2. So two numbers can be made to reach 3. So in this array also we can verify 3, no change. For 5, we can subtract a 2 to make it 3. So similarly, we'll do the same thing for all the numbers in the array. Also, like we discussed, we checked for num. We also need to check for num minus k and also num plus k. So we can just copy paste it 3 times and we can pass num minus k here and num plus k. So this is the advantage we get for using a function. So I'll just see 7. Let's just do the dry run for 6. So we have 6. The range is from 4 to 8. So we go here, we do the binary search to find the left and the right. So left is the smallest index, which is greater than equal to 4, and right is the greatest index, which is less than equal to 8. So by doing the binary search, we get the left as here. So here we'll have left and here we'll have right. So we can see that this 5 to 7 is actually lying in this range 4 to 8. So all these numbers can be made to reach 6. So from this we can count how many numbers are there. So we have 5 numbers in total, and among those 5 numbers, what is the frequency of 6? So the frequency of 6 is 1, and the remaining 4 numbers are from modifications, and out of those 4 you can only transform 2. So here we can see that we get the frequency as 1 and the modifications is the total minus frequency, which is 4. And while we return frequency. That means we return 1 and plus minimum of modifications and number of operations. So number of modifications is 4 and number of operations is 2. So the minimum of both of them is 1 plus 2, total 3. So with 6 as the center, we get the answer as 3. So when we calculate for 6 as the center, we also calculate for 6 minus 2, which is 4 as the center, and we also calculate for 6 plus 2, which is 8 as the center. So this will make sense for this input. We get this, yeah. Because for this input, the answer doesn't lie in this 2, 8, and 11. So let's see what happens when we quickly try run for this. Let's say we are doing it for 8. So 8 for 8, the range is 6 to 10. And when we perform the binary search, we get the left as here and right is also here. Because left is the smallest index greater than equal to 6, which is 8. And right is the greatest index, which is less than equal to 10. So which is also 8. So that means only one number can be made to reach 8. And among this one number, 1 is already present in the array and the rest of the 0 are from the modifications. So the total answer will be just 1. But once we are checking answer for the 8, we also check for 8 minus k and 8 plus k. So now let's see what happens when we check for 8 plus k. So 8 plus k will be 10. So we'll also check if 10 is our answer. So for the 10, again, we have the range 8 to 12. So the smallest value, which is greater than 8, is 8. So left will be here. And the largest value, which is less than equal to 12, will be 11. So right will be here. So now we have the total number of values is 2. And among these two, we'll see how many elements are present without modifications. So frequency of 10 is 0. So we have 0 in the frequency. and the rest all are coming from modifications. So that means this 10 is formed by modifying 8 and modifying 11. So out of these two, we have number of operations is 2. So that means we can modify both of them and the answer will be 2. So for this input, the answer is 2. So we got this by checking, not only checking 8, but also checking for 8 minus k and also 8 plus k. So, and at the end, let me just return answer. Let me test it. Okay, left equal to. Nums. And similarly, this should also be nums. Let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, we are first sorting the array. So this will be NlogN. And after that, this is just order of n operation. And this is order of n. But inside this, we are calling this count function. And this function has a runtime of log n plus log n. So total log n. So this is NlogN, and this for loop also NlogN. So total complexity will be NlogN. And for the space complexity, we are creating a hash map and storing all the numbers. So space complexity will be order of n. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. And let's catch up in the next video.